Testing. Testing. Okay. Hello. 1, 2, 3. Testing. Testing. 1, 2, 3. Okay. Testing. 1, 2, 3. Testing. Can you hear me? I'll speak loud.
If it would be too low, I suggest you and
move it higher. I'll speak louder.
Okay, so that's it. In 1 minute you can start. I will shut the door.
Sure.
We are sitting left top, so if anything goes wrong, just
I'll
look
panic
there
and you'll know.
maybe we will solve the thing.
Okay.
Probably we won't.
Okay. Okay, everybody, I'll get started. Thanks for coming all out today. Thanks for coming out. Today I'll be talking to you guys about a toolkit called Performance Copilot. And it's a method in which you can determine statistics and gather metrics across a whole network and an entire system. So, we'll go over a bit of an overview of the toolkit, the basic components, and using recent developments as examples, how you might fit into all this and how you might extend Performance Copilot to your use case and your solution. So, if I were to ask you today, how is your computer or your network performing, what would you do? Right? There are a couple different scenarios, a couple different tools. And the first one might be your logging mechanism, right? So you'd open up your log. These are good, but they're a bit after the fact, and they're all in one place, which is great. But different versions vary in the format, and they're not really organized either. You get all the information all in one spot, and you can't narrow it down. But that might be one way. You might also use profilers, right? Top, IOStat. These are also good, but they're not very malleable, right? If I want to change a metric or I want to discover something more, I'd have to go through and tweak everything, and I don't want to have to do that. Furthermore, between, as an example, with RHEL versions, the format of the sys suite changes completely. I would rather have a format that's consistent in the past 20 years, right? It makes life a lot easier. Realistically, systems administrators also make use of a variety of scripting languages, right? But the problem with this is I kind of refer to that as a black magic versus a science. Everybody's got their own little version. There's lots of duplicated effort. So we'd like to make things a little bit more, I guess, scientific and reproducible. So you have easier to expect or know what to expect. I'd love for Linux to be everywhere and ubiquitous, but realistically, in your environment, you probably have a little bit of everything. There might be some Windows boxes, Mac, BSD, and the tools for each platform differ, right? So we'd like something that works across everything. And really, proper analysis for what's going wrong on your machine potentially requires more context, right? We need to have more background information. So to solve all this, introducing Performance Copilot. So a couple key points. And it's got a Unix-like component design to it. It's a framework. So there's a lot of small programs that do one job and do them well, right? And you'll discover them as you go through. It complements existing functionality, which is key, because the easiest way to get someone disinterested in your new product is to tell them you're going to have to relearn everything. That's not the case. If there's certain parts of Performance Copilot you're interested in, just use those parts. If you don't need others, that's fine. It's cross-platform, which is great. We shipped a release last week. It works on Mac, BSD, various Linuxes. And it has consistent unit measurement, right? How often is your cache missing, right? Is it per second, per hour? There are rates, percentages. This is everywhere. When you're writing new metrics to include, that's one of the things you have to specify, right? It's very, very important. And we also know that what's most interesting for you to measure is slightly different than the person sitting beside you. They might be similar, you might be on the same team, but it's not the exact same. But likewise, we don't know what you want to measure. So Performance Copilot is extremely extensible, and that's by design. And it's open source. It originally wasn't. It was a project from SGI about 15, 20 years ago. And it's actually a great example of a project that was open sourced, maintained a community, and is still growing today. So how does it work? Well, there are two underlying components on any given machine that's running Performance Copilot. You have the performance metric domain agents, and you have the performance metric collection daemon. Now that's a bit of a mouthful, so I'll just say we have the agents, and those are the small programs that know how to gather the information. So you can have one for your kernel, one for your database, one for your web server. And then the PMCD, there's only ever going to be one. It's a very low overhead, stateless program that knows how to organize, orchestrate, and collect this information. Right? So it looks something like this. You've got the agents on the one side. We've got a lot more of these. You can customize the different machines that you have and what agents you want installed. And there could be many of them. There could be, it's basically end-to-one relationship with the PMCD, which communicates to these. After you get your initial installation, this is probably one of the first things you look at extending Performance Copilot with a specific application agent. And I'll give you a couple examples of this and how we use it. The agents can also be written in C, C++, Python, or Perl. And we're looking at also including things like JSON information in the future. So how many metrics do we expose by default? Well, the answer is a lot. On a default Fedora installation, it's about 1,500 metrics. And it ranges a wide variety of subsystems, right? So you have things like database accesses versus, I don't know, CPU load. And it's a very wide variety. So the problem you run into, right, we've got the kernel network databases and so on. How do you predictably name these things? How do you predictably find them, right? How do you specify what to measure, what we're interested in? And to do that, we have what's called the performance metric namespace. So that is simply a hierarchical naming scheme based on subsystem. So it looks like this, but it's actually really easy. If you're interested in, say, the number of packets you've received on the network, the metric name, how you identify it, would be something like network, TCP, receive packet, right? That makes sense. These names can be longer or shorter depending on your use case. Right? So we have a way to identify everything. On the flip side of things, you've got the tools, right? This is really a tools set. A variety of tools to interpret the data in a way that makes most sense to you. This could be importing into, say, a PDF if you have a report, or specifying the current value. And we'll get into a few examples of these. But one thing to note is this can all be done over the network, right? This is built in to TCP. There's common heuristics throughout the tools for specifying different hosts and containers. And we'll get into a few examples. So let's say you install it where to start. PMinfo would be a good one. You specify TAC-T, and that'll give you a quick help query. So as an example, if I'm interested in the PAPI subsystem, you get a quick output like this. You get the metric name and the basic idea of what it is. Right? Simple. PMVal will give you the current value of that metric really quickly. So let's take an example. So again, in the PAPI subsystem, the total number of cycles on your machine. Notice I've got access control there. There are some metrics that might be a little bit more sensitive. We want to take note of that and be careful. And it'll give you a bit of a metadata about it. So what host it's on, the units, the semantics. So this is a counter. We're converting it to counts per second. And then you'll just get values once per second spinning at the bottom. So this is cool, but a couple other ones. PM logger. I mentioned before having different versions of data formats suck. But PM Logger is our solution to that. It's a way to basically log the metrics you're interested in from various machines, right? Once again, it can be done over the network. And what we'll do is we'll record this information and keep it in archives. Part of our test suite upstream is to run our newest tools on archives 20 years old. So they're not going to change. You can expect consistency. And all of the rest of the tools know how to read from archives and your logs just as well as live data. Right? So you can make use of data from your web server, your database, and it all makes sense 20 years from now. So PM Logger creates logs for future analysis. By default, the logs are on 5 megabytes a day, rotates and compresses it. This is kind of useful if you want to aggregate all your information on one machine. You don't have to have them lying around everywhere. We have white papers basically to explain best practices. It's the equivalent of adding one line to a configuration file for remote host. And it's organized, right? I hear people wanting to throw all their information, their login details into Elasticsearch so they can search them later. They then turn around a couple of weeks later and go, I need new hard drives because there's too much information for me to log. And that just creates more problems than we're interested in. We're interested in solving that, and we keep this organized. So a couple of recent and future developments that are going on to kind of highlight how you might make use of this. First is the PAPI PMDA, PMWebD, deeper system introspection, and containers. So that might be a joke, but cache invalidation is actually a performance issue and something we want to track, right? A 0.5% increase in cache validation for, let's say, your level 3 cache can significantly increase or decrease performance. So there's this program out there called the Performance API, and it makes available the cross-platform, but it makes available the dedicated hardware counters on your machine. And it tracks things like cache invalidation, total instructions, total cycles. I mentioned it previously. And by writing an agent for this, we're able to actually express these values to the rest of the system, right? So in the overall layout, we would fit in right here, right? So it's just another agent. So you write this, it's in C, we expose these metrics, and we could use just PMVal like we did before, but I mean, I'm a programmer, I'm kind of lazy, and I wouldn't expect you to have one terminal open of, the total cycles, compare that to the branch misses, and sit there with a calculator trying to compare the values of the columns scrolling down. That wouldn't make any sense. So you do this, right? Just look at the values. But ratios and percentages are much more telling with these type of metrics. So this is a perfect chance for us to introduce PMIE, which is a way for us to use expressions to basically evaluate the performance of the machine. So this is a tool. This is our way of consuming the information, right? The flip side of things. So, like I mentioned, it's a way for us to form metrics-based expressions for evaluation. Ratios, counts, and aggregates. But what you do with that data is up to you. So you can raise alarms, log things, run commands. For example, if you find that the amount of queries to your database is dropping, but the amount of, hits to your web page is increasing through your Apache, then you can say, okay, something's going on here. I need to spin in a backup instance of the database and kind of take control of the situation. So, and you can run this on past data as well as live. So you can see, historically speaking, if there's been an incident, then you can turn around and test a rule. So let's take a look at one and run it across multiple hosts. So, and as an example with PAPI, right? So that cache miss, we can start off by creating a statement. So the level 3 total cache miss divided by the total number of instructions, right? This is a metric we'd be interested in. First thing you do to create a statement for PMIE to understand is multiply it by 100, so we get a percentage. And say if the percentage of total cache misses is greater than 2%, it's a pretty low number, you wrap it in an if statement, and then you output it to the log. right? And then all this would do is if you really prefer, you don't want to use PM logger, you just want to use the system logger, you can just have this message with all the rest of your data collection, right? You could perhaps spin up another instance of your application. So this is our way of making use of more information provided through agents. Another recent development was PMWebD. So this is on the collection and interpretation. And the idea is we have graphing tools already, right? It looks like this, actually. It's a Qt-based graphing tool. And you can see and analyze the overall performance of your system. So 1/5 into the chart, you can see that we've got a spike in memory usage and CPU utilization. 2/3 of the way into the chart, you can see that there's a spike in network usage. It's the overall performance, right? I would like to point out as well that you have the scale at the bottom. Like I said, units are everywhere, the ubiquitous. And then on the left-hand side, you've got if it's a percentage or if it's gigabytes or megabytes per second. So this is nice, but the idea behind it is there are other graphing tools available that people like to use instead. It's no fault of their own. It's what they prefer. So we would like to then make it easy to integrate what you already use. And two particular are Graphite and Grafana. So your way of collecting this information, or our way of exposing it to you, is writing a new tool for it, and then outputting it into Graphite and Grafana, which are just web-based, browser-based consumption methods. So it looks something like this. This is the exact same data running in Grafana. I'm not sure if any of you use this at all, but it's the same PCP metrics displayed through Grafana. Network at the bottom, kernel load, or CPU load at the top. And you can expand, highlight, and zoom, and then Graphite as well. Right, so this is, you can see the layout. There's no searching really needed. You pick the data that you're interested in, the subsystem you're interested in, the number of users, and you're set. For time. So we offer a wide variety of metrics, but things like latency, for example, aren't necessarily exposed by interfaces. So what if we want under the hood metrics? For example, with Linux, we expose a lot of things through /proc, but we want user computed values. And really, we need an extra tool for this. So introducing Systemtap. Right. This is a tool that System and my team uses to basically go under the hood with live data. And just as a quick introduction, you basically write scripts to output data from various points in your machine. So we like to combine, we call it the circle of observability. You've got debuggers, profilers, and trace points, or tracers. And we like to combine the strengths of all three. So you write a script, we write the kernel module for you, we'll insert it into the kernel for you, and then we'll present you with a report of your choosing, formatted how you like. So if you want to write a script, there are two major components. You have the Propoints, which are like the predicates, the points you're interested in, think like the breakpoint, the GDB script. And then what you do when you get there, right, so the handlers. So to write a simple hello world, you say pro begin, and in the handler you just say print hello world. Right, so when we want this to be hit, what do we do? You can do something like tracking a new bash process. So the predicate would be when the process bash hits function main, I just want to print out hello, bash has started. You can do stuff a little bit more complicated, listing functions in the order that processes call them, right? So people enjoy tracing through functions or programs. And what you do there would be have a predicate, so for example, bash, and then the regular expression, just star for function. And on the call, the handler would be something along the lines of print out the function name, so BP func, that function we provide for you. You run that, you run it when bash is running, you can see the startup going all the way through main. So this is kind of like an F trace, if you will, for a user space program. You can also figure out what types of probes by dumping the probe type, that quick command. It'll give you a full list, but it's things like kernel statements and functions or user space programs, net filter, There's statically defined trace points, and you'll get a full list. Right? We also have basic Java probing functionality as well in there. So what can you do with the information once you have it? We have the general gist of most scripting languages, like functions, macros, regular express and matching, error handlers, loops, aggregates, right? So you can do a lot of the stuff you might currently already be aware of. So starting to write a script, one thing I would usually recommend doing is listing what functions or what's available, right? So list the possible propoints. So if you're interested in what's, if you treat it like a black box, all right, you got a program, you're not sure what it does, you can start here. So if you specify -L, you go through, process Systemtap, and every function that starts with symbol underscore, and we'll list it for you. Right? It looks something like that. So you start to get an understanding of what's available to you. And then you can start looking at what variables are available to you. So if I use capital L on kprocess.create, which is when every time the kernel starts a new process, you get something returned like this. So two things I want to point out. One is where you have the $ variables. Those are what the variables actually being passed and the variables available. But realizing there's a lot of propoints available on your machine, we've gone and created some helper variables for you. So things like there's not a variable named new PID, but we're going to provide one to you because we think it might be useful. So context variables that exist in the program start with the $. Convenience ones don't have that. And we also have easy ways to make use of these types of things, right? So just like a typical library, we provide abstraction. So the kprocess.create example I just used is actually a kernel function, right? You don't need to know where exactly it is, but if it's useful, we'll provide it for you. For a list of all the probe points, you just use that function or option. And then helper functions to help you make sense of what you see. So again, using kprocess.create, if you want to know the name of what started, you can use the new PID variable that we provided. It'll actually match it to an executive name. So we run that, and instead of giving you the PID numbers, it's things like Firefox or Bash or OpenOffice. So to get a full list of them, use something like dump functions. So the helper variables, we go a little bit farther with those as well. If you want to run a script, say, that probes all the system calls being made in the system, right? So you can use the regular expression star for that. Each system call could have a variable number of arguments. So instead of you having to go through and create a handler for each one of them, it's easier to go through and append and prepend with $$ parts. So that'll pretty print all the output for you. Run that, and you'll notice that, say, syscall kill only has 2 versus, I don't know, read has 3. But you don't need to know the details. We'll do it for you. So trying to tie this all together quickly. Thinking right at time. So I've got this program named Terminator.c. And the idea of it is, in main, we're going to loop around and call sleeper. We're just going to sleep. And once we've done that 10 times, right, we're going to exit. So you quickly recompile that, we run that, and Terminator doesn't stop. And this sounds like a sci-fi movie, I don't know. So 10th line equals 10 seconds, it hasn't stopped, no good. So figuring out what's going wrong. You want to figure out where you can probe, along with, in this case, does main ever call the function, but you might want to know in a bigger program if it's ever being called. And can we do anything about it? This is a very small sample, but if you have a large, long-running program you don't want to restart, can we do anything about it? So first, where to probe? Use the -L. So our process name is Terminator, function star. In this case, we know the main does call sleeper, but again, in a bigger program, you might not be sure. So if we want to check, you can append after the process function, what is it called? Callee. So list me everything. In this case, we can see that It does indeed call sleeper. It's on line 4 of the file. And it does get passed to the context variable num. So that's interesting. Normally, we just add num++ to that. Right, it'd be done, easy. But if you can't fix and recompile that, right, we can't stop the program. We can write a script instead. So if we're going to write this script, we're going to have a variable to track what the actual number is. We're going to set it to -1 because it can never be that. We're going to be interested in when the sleeper function returns, is what value is going to be there. Well, if the actual value that's being returned is less than our variable, actual num, then that's an issue. So we want to increase our variable and then pass it back to the actual return variable. Right? So we're going to set the variable in the program. And then if it is running properly, we'll then just update our own variable and leave it be. So the result of that is we have access control with Systemtap, and changing a variable can be a little bit more intrusive. So -G is our way of saying, it's guru mode. It's okay, Systemtap, don't complain. And after 10 seconds have passed, the Terminator has been stopped. So Systemtap fits the bill for something like calculating network latency in the kernel. Right? We can grab context information. The thing is, it also has malleable output. So we can fit it to something we might expect, say in Performance Copilot. We're able to specify various Propoints, so we can expand this as we need later down the road. And we can express low-level information safely, right? You don't want to do this manually with perhaps, let's say you use uprobes to write your own script, your own module and sit it yourself. We take all the safety aspects for you, so it's a little bit easier. So it fits into PMCD or PCP by writing a new agent, the Systemtap agent. And for a specific example of the network latency, we formatted a Systemtap module. This is still being worked on, but if you format the Systemtap output to be JSON, and you have a Python agent which can easily parse JSON, then you can present that information from Systemtap to the rest of your tools easily. So we wrote a Systemtap script. I'm not going to get into the details, but the idea of it is to calculate transmission latency. And we specified a couple devices. 2 of them are dummies. We run that. At the same time, we have that agent installed, and then we run PMInfo on the Systemtap information. And you get output, right? You see the 2 dummy instances are 0. You get actual values for the transmission latency. On the flip side of things, for the total transmitted count, again, nothing for the zeros, but you get an actual value for an actual device, right? So this is our way of including new information. We're running out of time and trying to be quick. So containers, everybody's talking about them. The thing is, they're not just Linux-based, right? Performance Copilot has no real horse in that race. If you want to use containers on like BSD with jails, that's fine. But we have to be mindful of that. So we need to be flexible. And we also want to limit the dependencies, right? We don't want anything too Linux specific if we can avoid it. So instead of enhancing or extending PMCD or the protocols that we use, another thing is PMCD doesn't run as root. It's an unprivileged process, so we don't want to change that either. We write an agent that can run as root. We actually call it PMDA root. And what that will do is glean out the container information. So with the Linux-specific example, using control groups, we already have C group information that's already available to us. So we can grab that, and that's, if you don't know, the kernel's way of basically controlling different processes together in different subsystems. And then on the flip side of things, the namespaces, isolating different programs and what they see. So PMDA root, let me pop up the diagram again. We utilize our knowledge of the C groups and set namespace to jump around for you, right? Install that in the host, and the only difference to you is you get the PMVal, You specify the container, so whatever name you want. In this case, for example, Sharp Shockley. Docker happens to be the driver, but in the future, who knows, it might be Rocket. If we're interested in the number of threads running, and this is from the /proc, there's nothing been installed. This is a stock Fedora container. Number of threads, and I'm pinging redhat.com with my bash instance. And that's it. All right, there should be nothing for you to install to start on your containers, but you can start gathering information to analyze performance, which is, especially with the whole DevOps movement, being able to actually correlate information over a period of time and say, this is the change we made, and you can see in the graphs how performance has increased or decreased, is really critical. So it's our lightweight method of providing performance metrics from a container. So any quick questions? Yeah. Both. Everything's both.
Can we change the SAR data PCB and export to JSON format?
Oh, sorry, the previous question is the communication between the PMCD and the agents push or pull, and the answer is pull.
Okay, so the question I have is basically, if you have a SAR data from, let's say, RHEL 4, RHEL 5, RHEL 6, and RHEL 7, and the SAR data what I have, can I export them into a PCP archive and then export them again in a JSON format?
I don't think you'd be exporting the JSON format. You can import, so we've got tools that can import from like collectl and all that. And what that will do is put it in, like you said, the PCP format, in which case you can consume them in whatever method you want, right? If you want JSON specifically, you might have to write that tool yourself, but we have things like you can consume it in Grafana or Graphite.
Grafana is what Grafana does take JSON, right? Is it?
Yeah.
Grafana takes JSON, right?
In that case, I'm not sure, I didn't write that part, so I don't know specifically.
Okay.
But if it does, then yeah.
Okay.
So first, thank you very much for this. I'm actually a big fan of Systemtap, so this is really good to see.
Thanks.
Question about the integration there. You mentioned using a Python script for the JSON import. Is Python a strong dependency of this? In cloud images, we're trying to improve our ability to collect information, but very concerned about the footprint, both in memory and on disk.
Right. So in that case, yes, but that's something that's, especially with the whole container movements, we're aware of. So if we're able to separate that out for future, we will.
Okay, thanks.
Cool. No more other questions? Yeah, sure.
For the container capabilities you showed, who is the user of that? Would that be the system administrator or the app developer who's isolated to one specific container?
It's whoever has access to that container, right? If you can contact it on the host, like if you can specify the host that it's on, then you can access it. So it could be the system administrator or the developer.
Because I didn't know if you had suggested that you needed like root capabilities or something that the normal app wouldn't have.
To install that PMDA in the first place, yes, you need root capabilities. Right, so just the script to launch it, right? That requires root, so to install it on your machine, yeah.
It's going to be part of tool's container.
We are actively looking into what it would take to put it in the PCP super container, super privileged container right now, if that's what you're focused on as well. Answer your question, or?
You use the plain C, for example, in presentation. What other languages can be Systemtap used for similar languages?
Systemtap in particular? Well, sorry, the question was, with Systemtap, what other languages can it be used for? The main ones are C and C++. We have some Java support there as well. And we have, depending on your distribution, we've submitted some of these patches upstream, but we do have Propoints from statically defined tracers, like the STT markers. I'm not sure if we're aware of those at all. But we have those in the Python interpreter for every function, and I believe we have those in Perl too. I'd have to double check. But the main ones are C and C++. No worries. Yeah.
What's the best resolution you expect to get from PCB?
The data format that we have goes all the way down to nanosecond for resolution. If you can't actually grab the information that quickly for whatever reason, we'll try and interpolate that. Right? So if it's a nanosecond resolution, but we only have, I don't know, millisecond, we'll interpolate that for you and display it that way. With PCP? So the question was, is there aggregation of data across different hosts? Yes, right? And you also find with all the different tools, the heuristics of the options are similar, so you'll get to know that -H, whatever host here. Yeah.
Well, this is a sampling tool. Doesn't I can miss these points. As only the certain points are sampled, that's what I get.
Some of them are just simply collection, but things like the Systemtap one example in particular, or say example the PAPI one, right? So PAPI would be the hardware counter example. In that case, that's the actual values reported to us, and if we have to sample what PAPI is reported to us, then yeah. It's all depending on how fast you want to get the information back. Okay, if there are no other questions, please feel free to give us a shout. We're on IRC. We have various websites. PCP has been newly redesigned as well. And thanks for coming out.
Thank you very much.
I have a question about data storage because in practice,
And same.
Yeah, Arnaldo. Yeah, usually it's common.
All right. You have plenty of time.
So, yeah, they're working already, no? It seems to be. Isn't it perhaps no? It's going. It's going to, you see? It's going to
All right,
a second, but it's not going there.
What kind of it's HDMI?
HDMI.
All right, so we have to.
Oh, you have to.
Yeah.
Never works.
I have to switch here, but whoa. Koci.